Hello everyone. Today's lesson is about the Big Bang Theory, as well as evidence that exists to support the Big Bang Theory. Now, I'm sure you've heard of the Big Bang Theory, but if you haven't, it's the leading explanation about how the universe began. The idea is that it started from a small singularity, then inflated over time. So if you're interested in sort of what the word singularity means, there's a video below that you can go watch. Otherwise, I want you to pause the video and go take a look at the linked video on the origins of the universe. Okay, let's hope that you paused the video and went and watched that National Geographic Origins of the Universe. What you hopefully got from that is that there was a very small, hot, dense mass under crazy pressure, and this eventually resulted in a rapid expansion. Now, it's generally accepted that the Big Bang was actually an expansion, not an explosion. So, the term Big Bang Theory is a bit of a misnomer. There was no explosion in the classical sense of an explosion, but there was a very rapid expansion. So again, I want you to pause the video and go watch the video linked down below about how there wasn't actually an explosion, instead there was an expansion. Now, the next question is, well, how do we know about this? If it happened sort of 10 to 15 billion years ago, how do we even know? One of the biggest pieces of evidence we have that the Big Bang occurred is through something called redshift. And redshift is basically proof that the universe is expanding. Okay, technically I should say evidence, not proof. Okay, so what I want you to go do now is pause this video, and I'm going to attach a video or two below about redshift, and I want you to go watch those. Well, hopefully you paused the video and went and watched the redshift video. Here is a little diagram of ducks. So what's going on here is we have two ducks, and one duck is just bobbing up and down, just hanging out, and we have another duck that is flapping away or fluttering away and moving. And so if we're on the shoreline over here, happy little us, and we're watching the duck, then we can observe the ripples in the water around the duck, and they're going to be very, circular and uniform. But if a duck is moving, then those ripples will change. And so behind the duck, those ripples will sort of expand in their wavelength. And in front of the duck, the ripples will shorten. In the videos, it described wavelength with sort of the example of the siren of the car that's driving past, or the sound of the car. And so that's the Doppler effect, how the perceived wavelengths change depending on where the object is. Now, in the video, they used sound as an example of how these wavelengths will change. But when we're talking about sort of observing the universe, we're looking at light. So here's an image of the electromagnetic spectrum, and on this spectrum we have tons of different types of light, including gamma rays, X-rays, UV light, infrared, radio waves, and visible light. And so all of these are different forms of light, and the only difference in these types of light are the wavelength. So visible light is quite honestly the sort of light that is visible to humans. If we go beyond that wavelength range, we cannot see it, and same over here on the purple side. So what we're observing of these sort of moving galaxies is that the wavelengths are growing, or seem to be growing, and as a result are perceived color of the galaxies changes. So, for example, if we had one galaxy that hundreds of years ago may have appeared bluish, over time, this wavelength has increased and it's gone that way down the scale. And so we are shifting towards the red side of visible light. The wavelengths are increasing. And as a result, the perceived color of these galaxies that we see are becoming increasingly sort of more red or shifting towards the red. So I'll remind you that this increase in wavelength helps to demonstrate the expansion of the universe and therefore helps to sort of provide evidence that the Big Bang is a plausible theory. And so here's a bit of an image. First we had the Big Bang, where there was a hot, dense mass under high pressure, and then it began to sort of rapidly expand, and these galaxies are still expanding today, and the evidence we have for that is redshift. So, we've talked about the beginning of the universe, and now, at the end of our space unit, we will talk about the end of the universe. In theory, the universe will have to end, right? So people are very curious about this, and cosmologists have formed 3 possible ending scenarios. The first one is that the universe will simply continue to expand for an infinite amount of time. So basically, there will simply never be an end because space is infinitively large and will just continue to expand. One way you can sort of imagine this is if you recall the balloon from the Big Think video about the expansion of the universe. She describes how the balloon will continue to just grow and grow and grow, and there's no real sort of boundary of space. It will simply continue to expand. Next is the oscillating universe theory. Now, to oscillate means to swing back and forth. Well, in this theory, the idea is that the universe will continue to expand until eventually it hits an end point. Then it will begin to crumble back on itself and destroying everything that once existed. The final theory is the steady state theory, where eventually the universe will stop expanding and it won't shrink either. It will just sort of stop and just be or reach a steady state. So now the question is, well, which one do scientists favor? We'll get back to that in a sec. So at first, we have all this knowledge about how the stars use gravity and it pulls the atoms together, causing nuclear fusion to occur. And this generates a ton of energy, and this energy is the star's light. And our solar systems revolve around the star as a result of the gravity pulling everything together. And so there are also huge black holes that have an immense amount of gravity pulling things into it, and just our universe is so sort of based in this idea of gravity. And the idea is that this gravity would eventually cause the expanding universe to slow and eventually stop. But scientists noticed that through observations of supernova, this isn't actually true. And this is because of the force of dark energy, which sort of works against gravity. I encourage you to pause the video now and go take a look at the dark energy video I'm going to post below. Okay, I hope that you have paused the video and we can continue talking about scientists' preferred idea. Now, scientists are currently leaning towards the first theory, where the universe will continue to expand. However, there are two sort of versions of that theory. The first is called the Big Chill, where the universe will continue to expand and continually grow, and the objects in space would eventually become further and further apart from one another. Another name for the Big Chill is the Big Freeze. Alternatively, our other version of the first theory is called the Big Rip, where the universe will continue to rapidly and more rapidly expand, eventually being torn apart. Now, there's a really awesome TED Ed video that I've posted below that I want to make sure that you go take a look at. That's basically it for our lesson on the Big Bang. Just as a summary, recall that we talked about what the Big Bang is and how it's resulted in the expansion of the universe, our evidence that supports the Big Bang, which is redshift, as well as our three possible scenarios of the end of the universe. If you have any questions, let me know, and good luck!